Everybody, welcome back to another fun and exciting pre-calculus class. Today we're going to be starting on chapter number 5. The first lesson here is more or less a review of some Algebra 2 concepts that you should remember. If you don't, or if you just need a refresher, then pay special attention to this lesson. Maybe you look at this and you're like, oh yeah, I remember all this stuff. That's great. I'd still pay attention to the lesson because there might be some stuff in here that you don't remember or some stuff that was not covered in your Algebra 2 class. We are on page number 70 in your book, page number 70, and it's chapter number 5, Graphing the Trigonometric Functions. We're going to be doing lesson 1 today, Functional Notation and Interval Notation. Okay, what is functional notation? What is interval notation? Well, let's kind of back up the truck just a little bit and let's talk about what is a function first. That way we can kind of go from there into the rest of the lesson. So remember that a function is something that yields one and only one output per input. So if you put something in, it only gives you one thing as an output. I wrote that here. If you look right here, functions are expressions that yield one and only one output per input. What does that mean? Well, that means that this is not a function. X squared, well, let me do y squared equals 16. This is not a function. Why not? Because when we square root both sides to get y by itself, we end up with y equals plus or minus 4 as our answer. So we got two answers. Basically, quadratic equations are not functions. If you have to square root the one side, it's not going to be a function. Why not? Because it gives you two answers. So only things that give you one answer, like for instance, y equals x plus 3. No matter what we put in for x, so if x equals 2, well, y would equal 5. If x equals negative 2, then y would equal positive 1. Okay, so for every input, you only get one output. That's only one answer. So that's the idea of what a function is, kind of at the core of function. If you get two answers, not a function. If you get more than two answers, if you get, whatever, 3, 4, 5, it's not a function. The only one that's a function is if you get one output per input. Now you can keep changing your input. I kept changing my x value and my y value kept changing. That's fine, but I was only getting one output per input. All right, if you look up here, I wrote that the function of x and the g of x. Why did I write that? Because I want to show you two different ways of writing a function. Sometimes you have multiple functions. So a lot of times you'll hear me call this the function of x, and you'll hear me call this the g of x. I could also call this the f of x and this the g of x. But they're both functions, okay? So if you just hear me say function of x, that doesn't mean that this one's not a function. This one is still a function. It's just I call it the g of x. I could call it function g of x, but I don't say that a lot. And I pretty much always call this function of x rather than f of x. F of x is probably a little bit better way to say it. That way it's not confusing. But sometimes you'll hear me say it either way. So don't be confused by that. You could also have any other one. Typically we start with f because it stands for function. So function of x. And then we would go the g of x, and then we would go the h of x, and so on. So that's kind of how you say functions of something and how you write them. So let's look at this here. X is the independent variable. What does that mean? It's independent of anything else. In other words, you can put whatever you want in for x, because x is the independent. Now, it's not always an x. I say x, but I put it in quotation marks because it's not necessarily always an x. Sometimes it is and sometimes it isn't, but typically you're going to see x as the function of x. But you could have the function of whatever, of z. You could have different functions of different things. So if you see that, don't be surprised, but typically you're going to see function of x. Okay. Notice here the f of x is the independent variable. And what you do is oftentimes this replaces your y. Okay, so I have y equals 2x plus 5. You may recognize this. This is slope-intercept form. Y equals mx plus b. And so this is, I've used this because this is something that you should recognize right here. Now, this, if we put it onto the graph, this would be the x-axis, and this would be the y-axis. But something that you probably learned in Algebra 2 is that this is not always the y-axis. This changes names sometimes. Here in this class and in the future, you're going to see this be the function of x rather than the y line. Okay, so this is the function of x line. It's the same thing. Look, instead of writing this, we could write this. The function of x equals 2x plus 5. It's the same thing. All we're doing is substituting the y and the function of x for the y. All right, let's go down to this and let's talk about the domain and the range. And I am still in your book. If you're wondering where I am still on page 70. Actually, I just crossed over to page 71. So about halfway down, or the first quarter of the way down the page there, you're going to see in boldface print, domain and range. I'll jump over there, domain and range. Okay, so what are domain and range? Well, I wrote these definitions down. These are my definitions. The domain is the possible input, the independent variable values. So these are the x values. Okay, we'll write x over top of the domain. This is your x. Okay. Typically in a lot of functions, the x is going to be negative infinity to positive infinity. Okay, I know those are bad infinity signs. It looks like somebody sat on them, but I'm not very good at drawing them, so deal with it. I'm not an art teacher, okay? Sorry. So it goes from negative infinity to positive infinity. In other words, and you can put anything in, typically, not always. And sometimes this is, if it's a word problem, sometimes it's restricted by how many sales you had, how many parts you made, how many, whatever the word problem says. If it's a baseball player, how many hits they had, whatever, there's some sort of a limit on the independent variable because the problem tells you there's a limit. But a lot of times when there's not a word problem or there's no sort of restraints, it's just going to be anything will work. What does that mean? It means that you can put whatever in you want. You could put negative 1 million in, or you could put positive 1 million in, or anywhere in between, all the way to infinity. And that's the domain. In other words, there's no restrictions on the domain. The range, on the other hand, is the function of x, or we also call that our y point, okay? And the range is going to tell you, okay, so whatever, these are the possible outputs you could have. So if you put in 1 million, then this is a possible output to that. Now, sometimes your range is unlimited as well. Sometimes your range is negative infinity to positive infinity. But many times, your range is limited to, for example, positive numbers. Or, for example, numbers that have a, whatever, an even root or something, there's something there. There's something that's limiting it. Something in the equation. In this equation right here, something that limits it. Now, in this equation, nothing really limits it. What can limit this? What can limit your range? Well, things like square root signs can limit your range. Things like fractions. You can't have 0 as a denominator, so sometimes everything's included except for 0 because 0 can't be a denominator. What else? Absolute value can limit your range. There's a lot of things that can limit your range. All right, so that's domain and range. Now, again, that should be Algebra 2 stuff, but sometimes students get a little bit confused on domain and range. So I just wanted to hit that real quick. Last part of this lesson, we are going to talk about interval notation and inequality notation. What is an inequality? Well, an inequality is when two things aren't equal. I did put also an equal sign because in inequalities, sometimes you have that it's less than or equal to, right? Okay, so that's a thing. So I did put the equal sign there as well because you do have equality within inequalities sometimes because it can be like if you say all the students that are 18 years old or younger. So that includes the 18-year-olds. If you said all the students that are younger than 18 years old, that does not include the 18-year-olds because the 18-year-olds are not younger than 18. They are 18. So sometimes inequalities do include equals and sometimes they don't. So I wanted to put that just so you are aware of that. In interval notation, these two things mean two different things. And so I want to talk about that. This first one is a bracket. This bracket would be equal to, let's do this. Let's do less than or equal to, and let's do greater than or equal to. And this is what you would use when you had brackets. So if you have greater than, less than, or equal to, it's these equal tos, then you would use brackets. If you just had less than or greater than, then you would use the parentheses, okay? So in other words, the brackets, and let me kind of back this up. Well, I guess I can leave that there. So the brackets, we'll write it here, include, okay, and the parentheses exclude, okay. All right, what does that mean? All right, let's say that we're on a number line, okay. Okay, so let's do this example that's in your book. It's figure 5A on page 71. It says that -1 is less than x, and that x is less than or equal to +2. Okay, so now what we want to do is, hopefully you remember this, if it's not equal to, then we would come down here to our -1 and we would put a circle. We do not color that in, right? Why not? Because it's not equal to. And then we come over here to our 2 and we would circle the 2. However, the 2 is equal to, and so we would color in the 2 dot. Okay, you remember how we did that? All right, that's algebra 2. That's even algebra 1 a little bit right there. And so now what we would do is we would test a point. So let's test the 0 and see if we need to color in the line between. So -1 is less than 0, and 0 is less than +2. Correct. So that checks, so we would color in this middle part right here. So that is what's called inequality notation because we used inequality signs, okay? So that's inequality notation. Now, how can we do this? The same question, I'm going to leave that right there. I'm going to leave that question there, okay? And then I want to do this, but I want to use, remember what we called it? Interval notation, okay? So I want to use interval notation now. Well, how do we do that? Well, we're going to use these things right here. Brackets, if it's what? If it's included. And we're going to use parentheses if it's excluded, okay? So let's just rewrite this thing using our interval notation. So we're going to say -1 is what? Included or excluded? Okay, -1 is excluded. So we're going to put a parenthesis on that. And then we're going to put a comma, and that means to or until. It's kind of like this, these signs, as far as we're going to include these into the thing. So we'll put a comma. This is kind of going to look like, like our coordinate points, but it's not going to be because you're going to see why not in just a second. And if we put a bracket on this one, why did we put a bracket? Because that one is included. Remember this? When we have the bracket up here, we have the equal sign with it. So that one's included. So a 2. All right, so now we want to graph this on our number line. So we would come over here to the number 1. Now, instead of drawing a circle this time, we are going to put our comma or our parenthesis right there on the number 1. And, you try kind of draw it however, but you want to get it so that it doesn't look like it's in front of or behind the number. You just want to get it right on the spot if you can at all possible. That's just going to look the best. Okay, number 2, then we're going to come over to the number 2, and we are going to use the bracket here on the number 2. So you're going to come in here and you're going to bracket the number 2. And then you would just draw your line in between those. Okay? And so basically it's the same thing, but just a little bit different way of making our notations on there. Let's just do a couple more examples here. We'll do this example number 2 in your book. This is on page 71. So here we go. Here is our inequality. And we want to graph it though, but it says to graph these using an interval. Okay? So we're going to graph it using an interval. So what we do is we look, okay, that is included and that is included. So we're going to be using brackets. So you'd come up here and bracket that, and then your interval would be between those. Next page. So now I have -3 is less than x is less than 1. Both of these are not included. Those are excluded values. So we're going to come over to -3. We're going to put a parenthesis. We're going to come over to 1 and put a parenthesis. And then we're going to color in between those. All right, and then the next one, we have one that has included and excluded. So the 3 is included, so it gets a bracket, and the 7 is excluded, so it gets a parenthesis. And then we'd color in between those. Last thing I have for you, I want you to look on table A in your book on page 71, and you will see there's a little table with the different things, inequality and intervals, and they have a name for them. So if they are both closed, in other words, they're both excluded values, that's called a closed interval. Closed interval. The next one is if both are open-ended. So in other words, they're both excluded values, then it would be called an open interval. And then I've seen this next one called two things. I've heard it called half open, but I've also heard it called mixed interval. So maybe you'll hear it called mixed interval. And then that's when they have one of each. And now this one is when both of the first and last are numbers. So in other words, it's bounded on the number line. There's a boundary on the number line. Then the last one is when you have either negative infinity or positive infinity, and that's called unbounded. So in other words, it just goes into infinity on one side. That's unbounded. So if it has a boundary on both sides, it's bounded. If it has an infinity on one side or on both sides, then it would be an unbounded. Okay? Alrighty, well that's all I have for you in this lesson. Hope you learned something there. Hope you had a good review. We need to know this stuff going forward into the next set of lessons. Okay, we'll see you later. Have a good one. Bye-bye.